or 9? All right, how do I use the relationship? Among the sides of a special right triangle. All right, there are two types of special right triangles. Only two. Okay? So there's only two types of special right triangles. It's on the board. All right, the first one is a 45, 45, 90 degree. Forty-five, 45, 90. Every triangle is going to have a right angle, yes? So we need to make sure we have the right angle. Now, if this is a 45, 45, 90, that means both these angles are 45 degrees, right? Make sense? What can I cut in half to get a 45, 45, 90? What's cheap? A square. Why not a rectangle? What? Why not a rectangle? Yeah, the sides are not the same. So on a 45, 45, 90, it is the sides, and these bisect the angles. Your diagonals bisect the angles, which is why it works. All right? So let's talk about this. This has a special ratio. If this is 45 degrees and this is 45 degrees, when you open up something that's 45 degrees, so if I open up the cabinet, and let's just pretend that's 45 degrees. If I open up the second cabinet and it's 45 degrees, are they open the same amount? Yeah, right? So if they open the same amount, then does that make these sides the same? Yeah, it does. So our ratio is 1, 1, and the hypotenuse is a radical 2. Now your ratio is going to be set up in a special way. When I'm looking at this, if this is 45 degrees and this is 45 degrees and these sides are exactly the same, well that makes sense because we said we cut a what in half? A square. And when you cut a square in half, aren't your sides the same on a square? So that's why it works. So we're going to make this special little chart. It's called degree, ratio, opposite. Degree, ratio, opposite. And when I look at it, the degrees literally come from the degrees of the triangle. Well, what kind of triangle do I have? (45, 45, 90, right? So we're going to label 45, 45, 90. The first two columns you will not have to think of. You just have to memorize them. Do you understand? The second one is the ratio. Bless you. I've already set up the ratio. It's 1, 1, radical 2. So if they're the same, if this is 5, then what's this side? 5, right? If this side is 4, what's this side? 4. They're exactly the same. So there's nothing really special. Now the opposite. Opposite means it comes from the triangle. I'm going to take it out of the triangle. And that's going to make sense when I get to the actual examples. For right now, we don't really understand what the opposite part is. The part we only need to know for now is degree and ratio. These two need to be memorized, which is why they're in a special color. They're always the same. Got it? They're not going to change for 45, 45, 90. It's always going to be 1, 1, radical 2. Okay? For those of you that get to pre-calc, it was on her board right now. She had this thing on her board. Okay, it doesn't change. This is what changes based on your picture. Okay? So we're going to come from the triangle. Now, what does it mean to be opposite? If I say go to the opposite side of the room, where are you going?
To the opposite side.
So across,
Yeah.
right? So if I were to go to the opposite, I'd end up in that corner, right? So opposite comes from the triangle, and we need to remember it's across. Okay? Second type. There's only two types. Is your 30, 60, 90 triangle. This one's probably when I cut a what? Not a square, but a what shape? A rectangle. Still going to have 190 degrees. You're going to have one that's a 30 degree, one that's 60 degrees. So earlier we said if we open one that's 45 and open another one that's 45, they're the same, right? But if I open one at 30 degrees and open one at 60 degrees, which one's bigger? You're 60 degrees. Why? Why is 60 bigger? It's a bigger angle, right? It's more than 30. So what side's smaller? 30. What side's going to be the smallest side no matter what? Your 30. This is your shortest side. What's the longest side on the whole triangle? Which one? The 90. Which is your what? That's with an H. Hypotenuse. Okay? This one has a ratio also. Your 30 is 1. Your 60 is radical 3. And your longest side, your hypotenuse, has a ratio of 2. So I'm still going to make the chart down at the bottom. So do you see why you need to memorize it? Because the chart looks the same, but based on your degrees will determine your ratio. So what triangle do we have here? What are the degrees of your triangle? 30, 60, and 90. Our ratio is coming from right here. It's 1, radical 3, and 2. Where does the opposite come from?
The triangle.
Yes, it does. We good? It's example time. All right, examples. Bless you. All right, so there's my picture. It has x, x, and 2 radical 2. It does not tell me if it's a 45, 45, 90, or if it's a 30, 60, 90. What do you think it is, though? Why 45, 45, 90? Because the x's are exactly the same. I can't have one x be 4 and the other x be what? 3. That doesn't make sense, right? They have to be exactly the same. So for them to be exactly the same, it's going to be a 45, 45, 90. What I want you to do is make your chart, but don't do anything else. Fill in degrees and ratios and make your chart. Sorry, I forgot to tell you. We can just put D, R, N, O. If you wrote it out, it's fine. But that's because I didn't answer the phone. All right, so what's your degrees? What did you say it was? 45? 45? 90. What's your ratio? 1, 1, radical 2. Yes? Okay, opposite comes from where? Comes from the triangle. So the easiest one to find is the 90 degree because it's labeled. So what's your 90 degree opposite? 2 radical 2. So then what's your 45 degree opposites? X and X. Do I need to solve both of them or just one?
Just one.
Why? Because they're the same, right? So if I just solve one of them, it works out. So remember those proportion things you guys just learned? Yeah, we're going to set one up. You ready? Right here? You get to actually ignore the degrees. Do you see this right here? We actually have a proportion. It's 1 over radical 2 equals x over 2 radical 2. Do you see where I got it? You see how I did that? Go ahead and write it. It's literally just right there. All right, and how do you solve proportions? Cross multiply. So we're going to go ahead and cross multiply. What do we get when we cross multiply? What's 1 times 2 radical 2? 2 radical 2. How many pick up your head? Equals what's radical 2 times x?
X radical.
Let's put radical 2 in the front. Yeah? How do you solve for x? Not plug in. Divide. Divide both sides by what?
2.
Not 2. Radical 2. That becomes 1, and so does that. Yes? So what does x equal? 2. Wonderful. So if this x is 2, is this top one 2? Yeah, they're the same. We good there? Question? Okay, second example. All right, I've given you your triangle. This says radical 3, that says x. There's an angle right there that you can see. Go ahead and make your charts. Degree, ratio, opposite. Ready? What's your degrees? 30, 60, 90. What's your ratio? 1, radical 3, 2. That just has to be memorized, yes? Okay, opposite of 30 degrees. So go 30 degrees, go opposite. What do you see? Radical 3, very good. Opposite of 60 degrees. Wait, where's 60 degrees? Oh, up at the top. So opposite of that is what? X, good. Opposite of 90 degrees. No, we don't want to call it x because there's already an x. Do you have anything there? No, if I don't make you it, just put a line through it. If I gave you a second variable, then you would solve for it. But because there's only one variable, you only have to solve it once. Got it? Now, when I do this, which one am I going to use? What 2 degrees? 30 and 60. Why not 90? Because I don't know anything about it. So we're going to go ahead and use those. We're going to set up 1 over radical 3 equals radical 3 over x. Go solve it. What does x equal? What are you multiplying? 1x equals what? What are you multiplying? You should know how to multiply fractions here. Radical 3 times radical 3. What's the square root of 3 times the square root of 3? Square root of 9. And what is the square root of 9? Thank you. Okay. We did this first semester. You were not here. We did this in August of first semester, guys. August. I know it was a long time ago. We good? Remember this? A little bit. Let's do it again. Now I've given you how many variables? 2. So how many times are you going to solve this problem? Twice. You must solve it twice. Okay? So set up your chart, and then I'm going to talk about it before you solve it. What's your degrees? 30, 60, 90. What's your ratio? 1, radical 3, 2. Yes? Okay, opposite of 30 degrees is what? 9. Opposite of 60 degrees is what? Very good. Opposite of 90 degrees is y. Who has this right? Good. This should be easy, yes? Okay. Who can give me one proportion? 1 over radical 3 equals what? 9 over x. Very good. Who can give me the second proportion? What is it? Hold on, I can't hear. Okay, if you do radical 3 over 2, then you get x over y, but that gives you 2 variables. Don't ever do that. There's a reason why. If you accidentally solve this incorrectly, this one's pretty easy, but let's pretend you did something wrong. Then that makes what? The other one wrong. So go back to what you know. Which one do I know? Do I know this one? I know the 30. So I'm going to set up 1 over what? 2 equals, there you go. Did you hear what I said? Never use the the one you're finding to solve for the last one. Always go back to what you know. So always go back to that first one. Make sense? Because then you get 2 problems wrong versus 1 if you mess up. All right, cross multiply and solve.
Wait, where'd you get radical 3 from again?
This?
Yeah.
There.
Oh, it's always going to be there?
Yep. 2 columns you have to memorize. Degree and ratio don't change. So what do we get for x? X equals what?
1. Oh, wait.
You guys are lost in your radicals, which is scary. Remember, you're allowed to multiply radicals together. You are not allowed to multiply whole number and radical together.
Oh.
You're allowed to multiply whole numbers and radicals together, but they have to be the same. So if it's a whole number and a radical, you just literally stick them next to each other. Do you remember that? A little bit? Some of you look at me like I'm speaking a new language. So what's this one? 18.
So there's going to be 2 answers?
How many variables did you have?
Oh, yeah.
So how many answers did you have? Okay. We good? Here. I'm going to throw a reminder over in the corner. Because if that's a little bit scary, then this is going to be scary. A little review. Here we go. If you are given something that looks like this. Are they on the roof? Yes! The air conditioning. Alright, if you have something like this, make a note. You cannot leave a radical in the denominator. We went over this a long time ago. You can't have a radical in the denominator. Since you can't have a radical in the denominator, you need to get rid of it. In order to get rid of it, gentlemen, you're going to multiply by the denominator. Can I multiply radical 7 and radical 2? Yes, I can. What do you get? Radical 14. What is radical 2 and radical 2 multiplied together? Radical 4. What can I simplify in this picture right now? 14? No. What can you simplify? The square root of 4, which is what? 2. Am I allowed to reduce those?
Yeah. No.
Why? Radicals go together. Whole numbers and radicals don't go together. Is that a whole number?
Yes.
Is that a radical?
Yes.
So can I simplify them? No.
That's the answer.
Got it? If I had a whole number on the outside, like a 2, could you simplify them? What would you simplify?
It should be 7.
They would cancel. It would not be 7. Got it? Makes sense? Questions? The part that's going to confuse you the most, there's 2 things. One is going opposite, if you don't go correctly across. Number 2 is if you mess up on your radicals. Otherwise, you can set it up completely fine, but the radical work is where you'll get confused. We good? All right, summary.
Can we write it like on the side? Or
No, you're going to go over there behind the door. There's these lovely little things called index cards. You're going to write it on the index card, and you're going to tape it into your note.